piecewise function. And notice this is being developed in two pieces. The first piece goes between, remember this guy right here is always the domain. The first piece goes from x less than -2. The second piece picks up at x greater than or equal to -2. So it looks like my break point, and I'm going to put my wall in first, is x equal -2. And if I'm going to graph it to the left of -2, I'm going to graph y equals x plus 3. To the right of -2, I'm going to graph y equals -2x minus 3. So I can actually, I think, move that up. So what is the domain? Well, it's x values, so I know that the first one starts at -2, and it's an open dot because it does not include, and it's everything smaller than it. And the second one includes -2, so it fills in the dot and everything bigger than it. So what is the domain? What's shaded? All real numbers, yeah. Now the range will get off the graph because I haven't a clue what the range is. You just can't get it from just looking at the formula for the function because I don't know what it's going to do. And so x-intercepts and y-intercepts I'm going to let you get off the graph itself because the y-intercept is easy. Now, why would I say the y-intercept is easy? Well, the y-intercept is easy because it's where x equals 0. It's defined by an x value. And I know which function that x value occurs on. Which function does it occur on? -2x minus 3, right? Because x equals 0 is bigger than or equal to -2, so it's going to be on this second graph. Whoops. So it's going to be on the second graph. So what would the y-intercept be? Well, that says that if I have y equals -2 times x minus 3, if x equals 0, then y equals -2 times 0 minus 3, or y equals minus 3. So the y-intercept is going to be 0 minus 3. And then we'll get the x-intercepts off the graph. That's kind of cheating, but that's a better way to go. That's the easy way out. Cuts down on the algebra. Okay, so here we go. We're going to graph this sucker. So on the left-hand side, I'm going to graph and x plus 3. We know x must be less than -2. Good news is this is a straight line, so if it's a straight line you only need 2 points and then you connect the dots. I'll put in an x value of -2. This one is going to be an open dot because you notice that x is strictly less than -2. And I'll put in -3 because it's less than -3, and then I'll just join the 2 dots in a single line. If x equals -2, -2 plus 3 is +1. -3 plus 3 is 0. I found the x-intercept, didn't I? -3, 0. Y is 0. That's an x-intercept. Cool. That wasn't a plan. So, -2, +1, open dot, -3, 0, because it's in the domain, it's a solid dot, and then I just join the two dots, and that's the graph of the first one. Now the second one is y equals -2 minus 3. So I'm now going to do my x, and this is -2x minus 3. And remember, x has to be greater than or equal to -2. So I'm going to start with -2. This is a solid dot. Because of the equal sign it includes, I just need a second point. That itself is also a straight line. You only need 2 points, yippee. I'm going to pick my second favorite point, or actually my first favorite point, 0. And why would I pick 0 instead of -1? Because, yeah, I don't like negatives. And besides, 0's in the domain, right? That'll kill the x's, and it's a looking right. So if x equals 0, y equals -3, and now I have to think. -2 times -2 is +4. +4 minus 3 is 1. So if x equals -2, y equals 1, it fills that dot in. And if x equals 0, y equals -3. And now I connect the two dots because it is a straight line. And this is a total graph of f of x. And if you did it in only one color, it will look like it's a solid graph. But when I do it in two, the green fills in the red hole. So now we can read off the range. The range starts at -infinity and stops where? At +1. So the range is going to go from -infinity to +1. That's a solid dot, so I include it. And now I can also read off the x-intercepts. Now I'm going to have to guesstimate if I'm going to get it off the graph. The first one we know. The first one we know because it lands right smack on that thing. It is what? -3, 0. And the other one is right here, which looks like to be about what? If you had to guess. -1.1. No, not -1.5, excuse me. Now, would be -1.4 be a wrong answer? No. Would -1.3 necessarily be a wrong answer? No. You need to be in Mr. Rogers' neighborhood of about that. -1 would be a wrong answer. But it depends upon, I drew the line freehand. If you draw it freehand in particular, you may be a little wobble there, right? So you're going to be in and around that when you read it off the graph. And you can see it's on the green graph. So if I wanted to calculate out exactly what it was, do I know what graph I can need to do the calculation on? See, it's the green one that intersects the x-axis. It's this guy. That would give me that point. That means I could use this one to do the calculation to find the true x-intercept once I have the graph up. And I know which graph the stupid x-intercept is on. You guys are no fun today. I mean, it just is. Yeah, it's true, you are.